Good morning, friends. This is prof.a.k.chaubey, Professor Chaubey Physics Class, under the heading Physics Made Simplest. Well, I am going to do some problems today based on the electrical measurements. So I have written one problem here. The problem number 1. The Wheatstone's bridge is arranged as follows, like this. AB is 1 ohm. This AB is the resistance of 1 ohm. BC is of 2 ohm. And CD is of 3 ohm. And DA is of 4 ohm. So 4 resistances, 1, 2, 3, 4 are arranged like this. And the B and D connected with a galvanometer G of 5 ohm resistance. And A and C are connected to a battery of internal resistance 1 ohm. So this is the circuit of Wheatstone's bridge. Now what we have to do? Calculate, number 1, magnitude and direction of current through galvanometer. What is the current through galvanometer? What the amount and what the direction? Number 2, the resistance between point A and C, that is the A and C. What the resistance between A and C? And find out the current, whether current passing through VD or DV in galvanometer. So we are assuming that I1 plus I2 is the current coming from the battery. This battery is say of 4 volt. Now, yeah, this is the 4 volt. Yeah, it is somewhere 4 volt, yeah. So we assume that some current I1 plus I2 is coming through this. Here at the branch where the 2 branches are there, A and B and C, the current divided, I1 goes in this branch and I2 goes in this branch. So the total current is I1 plus I2. We are dividing here current into I1 and I2. When here at B, we are assuming that B is higher potential than D, so current passing through galvanometer direction as shown through B and D. Ig is the current passing in the galvanometer. Then I1 was here, Ig goes this side, so I1 minus Ig is going in the resistance BC. And here, at this point, I2 was coming here, so I2 is coming here and Ig is also coming here. So the current becomes here I2 plus Ig. And finally here, because it is I1 minus Ig, it is I2 plus Ig, so Ig cancels, so current here becomes I1 plus I2 again. This is the complete circuit. Now we have to calculate the value of Ig, and we have to find out the equivalent resistance between A and C. So this is the problem. I can now solve this problem. I will try to solve this problem. So what I do, I consider the loops. There are 2 loops. One this loop, A, B and D, A like this, other this loop. So we consider both the loops. That is the. So what we do, consider loop. Consider loop, say A, B, D, A. Means A, B, D, A, this loop. And now apply the Kirchhoff law in this loop. And applying Kirchhoff voltage law. To this loop. So we write equation applying Kirchhoff law. We know voltage law. What the voltage law? Voltage source, that is EMF, which is connected in the circuit, and the total potential drop, IR drops. The EMF applied is equal to the potential drop, IR, taking into account the proper direction of current. When we take, say this current or this current, say anti-clockwise or clockwise, I take one as plus direction because both are opposite. Here, this goes like this, and this goes. So we are starting say clockwise, then we take the IR drops like this, minus, and this is opposite, so both opposite. So we write the voltage law, that voltage, and here there is no voltage source, so that is 0. So we write the Kirchhoff equation that I write minus the IR drop, means R is 1 ohm into say what is the current I1. Why minus? Because I am taking this current as opposite current. I am taking this current as a positive. So both, or you can take this negative and this positive, immediately. One positive, one negative. So minus 1 into I1 and minus this also current is also say anti-clockwise. So 5 ohm resistance and Ig current. So minus 5 into Ig, and others is the plus. This is the clock, this is the opposite current. This is the clockwise, this is the anti-clockwise. So plus 4 resistance I2. So these are IR drop, potential drop, I into R, I into R, I into R. And there is no applied source, that is 0. Voltage source is 0. So this equation we write, or we can write this simply I1 plus, this is, I transfer this on the other side. I can write that I1, this I1, and this is a minus and this is a plus. So plus 5 Ig and this is a minus 4 I2 is equal to 0. So I write this equation number 1. Then loop BCDB. For the loop BCDB, I again write the voltage equation and see what the source is 0, and we write the current. We take I1, this the clockwise current say negative, anti-clockwise say positive. So we take one direction. So this is a minus 2 resistance and I1 Ig opposite side. So minus I1 minus Ig into 2 resistance, and then this and this. So what we write here, 3I2 plus Ig, 3, here I2 current is I2 and this Ig goes there. So, and this is say anti-clockwise. So clockwise I am taking say opposite, and this anti-clockwise I am taking positive. So plus I2 plus Ig current, and through the resistance 3 ohm, like this. So into 3. And next, what else? We have say, what next? This is say 5 Ig. This current is a direction. So that we write plus 5 Ig. This current direction is same. So, and this is opposite. So that is the plus this 5 Ig. 5 this and Ig current. 5 Ig. And this was I2 plus Ig into 3. So this was, yeah, 3I2 plus Ig, good, minus I1. This is the minus I1 minus Ig. So that is I1 minus Ig. This is the minus current. So this is the clockwise, and this is also clockwise. It's anti-clockwise. I2 plus Ig. So, and this, there is no voltage source equal to 0. Or we write so here 2I1. I1 minus 5, yes, 2 into I1. So this 2I1, we write 2I1 minus, this is ig plus, and this is 3ig, 3ig, 5ig, 5ig, 3, 8ig, and minus 1 is 10, so 10ig. And then I think we have twice I1. I have multiplied minus here, so twice minus, this becomes minus. So this becomes minus. Yeah. Because minus, I am multiplying with minus also, this becomes minus. 10ig. Throughout minus. And minus, multiplying with minus also, so this 3i2 minus. Because I am making I1 plus. So twice I1 minus, multiplying minus also, so I1 is plus. Minus 10ig minus 3i2 is equal to 0. So this I have another equation too. Now loop FAB. Loop F, this point we have F and E. This is the E, this is the F. F, A, B, F, A, B, C, E, F. This loop I have applied. Loop F, A, B, F, A, B, and C, C, E, F. For this loop, write the voltage equation. Same, we are considering the loop different and we are writing only voltage law so far. The voltage law for this minus I1 into A for this current I1 here. There is a clockwise, so I am taking minus. So minus I1 into 1 and then minus this current, also same direction, minus 2 I1 and of course minus Ig, this current. And what else? Minus I1 plus I2, this in the same direction, minus I1 plus I2. And that this current is passing through, in this circuit, this current is passing, coming like this. So this is 1 ohm internal resistance, so into 1. And what else? Plus 4, because there is voltage source here. So either total voltage are 0 or applied voltage is equal to that. So we can write total voltage plus 4 volt is equal to 0. We can write this simply. We can see I1 here, take I1, and we can write the equation 4I1 minus 2Ig, 4I1 minus 2Ig plus I2 equal to 4. I transfer this 4 and minus multiply also. So this. Now this equation number 3. So solving this equation with Kirchhoff law, I have these 3 voltage law equations. Now multiplying equation 1 by 2. Multiplying equation 1 by 2. This equation, we multiply by 2. And subtracting equation number 2 from it. Because equation number 2, we have here 2i. Here I have 1, so I multiply by 2, so that, and subtracting equation 2. This is simple algebra now. Solving the equation, you multiply this equation by 2 and subtract this equation. So this I will be cancelled, I1 will be cancelled. You can write, we get, by doing this, we get by 2, multiplying by 2. So this will be cancelled. We multiply by 2 here, so 2, 5, 10 Ig, and this 10 Ig subtracting here, minus plus. So this I write, this is minus, yes, what I get? Multiply equation number 1 and then by 2 and then adding. Why subtracting? Because this is 2i1 and this is 2i1 minus. Sorry, 1, this is here, okay. So multiplying this by 2, so 2i1 and subtracting, then this cancels. And this 5ig and this is subtracting, so this becomes plus. So 2 times is 5, so 5, 10 plus 10. So this becomes 20 Ig. I1 gets cancelled. 20 Ig minus 5 I2. Because this is 2 4 8 I2 and subtracting this 3. So this is subtracting becomes plus. This is minus, so minus 5 I2 is equal to 0. Is it okay? Now I can remove this just because I have no space. So now multiply equation 4. This becomes equation 4. Now multiply equation 1 by 4. By 4 and subtracting equation number 3. What do you get? You do this, we get 22 Ig minus 17 I2 equal to minus 4. So this is equation number 5. Multiplying equation 4, this multiply equation 4, this by 17 and equation 5 by 5. Means we multiply this by 5. So this becomes 17 to 5. Multiply this by 17, so this becomes 17 to 5. And then after this, then we get here, say multiply this by 5 and this by 17. So what we get? 340. 17 is here, 340 Ig, this, minus 85 I2 is equal to 0. This is number 6. and this multiplied by 5. So this becomes 5 means 110 Ig minus 85 I2 equal to minus 20. So is it okay? Yeah. Now we have these two equations. From this, subtracting equation number 7, subtracting equation 7, subtracting equation 7 from 6. Subtract this will cancel, and subtract this 340 minus 110. What you will get? 230 Ig, this here. 230 Ig is equal to this. 230 Ig is equal to, you subtracting here, so this becomes plus 20. So Ig becomes 20 upon 230. So that is 0.087. 0.087 ampere. And this is Ig, we have taken positive from B to D. We assume that current direction Ig was from B to D. That was, we have taken that diagram. So we got this Ig. Therefore current is, current through galvanometer is 0.087 ampere in the direction BD. So we know the current and we know the current direction also. Okay. This gives the value of the current and direction of the current also, that is direction through BD. And now what we do? Say we have to calculate one more thing. What is that? We have to calculate the AC resistance. So for that, I have to rub because there is no place. So now what we do? Substituting Ig in equation 4. Substitute Ig in equation 4. What you get? We get I2 is equal to 0.3, I2 is equal to 0.348 ampere. Substitute Ig in equation, substitute Ig equal to where Ig we have calculated, yeah, 0.087 and I2 this 0.348. Both these values, Ig and I2, you substitute these here in equation 2. If we do this, we get I1 equal to 0.957 ampere. Now current supplied by battery, current supplied by battery is I1 plus I2. So we have I1 here, that is 0.957 plus 0.348. So this becomes total current. You add the 1.305, 1.305 ampere. So we know total current. And PD between A and C, that is the potential difference. We have to calculate the resistance between A and C. So PD, potential difference, A and C. We have applied the circuit current is battery connected across A and C. So what the PD? We have 4 volt. PD between A and C, that is EMF battery minus drop in the battery. That is the EMF minus drop of the voltage. So drop of the voltage across resistances, and that is a drop of the voltage in battery. That is our internal resistance. So that internal resistance will have some drop. So that will be EMF applied as 4 volt and minus 1.305. Because this is the current passing through that, and into 1 is the internal resistance. So that is the drop, voltage drop in the battery because it has internal resistance. So that becomes 2.695. 2.695 volt is a PD. Now resistance between A and C is how much resistance? PD between A and C divided by current. So current we have this, PD we have this, so resistance will be how much? Across AC will be 2.695, 2.695 this PD divided by the current 1.305. So this becomes, resistance becomes 2.065, 2.065 ohm. So this is the answer of the problem. Friends, now I take a break for 5-10 minutes and then I will be back again. I will solve some other problem. Friends, so thank you very much.